Hey, you!
Who, me?
Yeah, you! Are you bad at football?
Of course not.
Do girls play better than you?
No. Don't film me. Luckily, we have world-renowned physicist Dr. Bates to teach us. Today, I'm going to teach you how to kick a football properly by Bernoulli's equation. Bernoulli's equation can also be written as work done plus kinetic energy plus gravitational potential energy, which gives us a constant. Work done, which can also be written as force times x component being the horizontal perpendicular distance from the force. This is further added to kinetic energy, which can also be written as half mass velocity squared. This is further added to gravitational potential energy, which is mass multiplied by gravity multiplied by the y component being the vertical height. The force from work done can also be written as area multiplied by pressure, and you would notice that mass is a common factor of kinetic and gravitational potential energy. And mass has an equation of density multiplied by volume, and volume has an equation of base area times height. And in this case, the base area being A, while the x component being the height. You would then notice that area multiplied by the x component is a common factor. Finally, after removing the common factor, which is ax, you would get p plus half rho v squared plus rho gy, as mentioned earlier, y being the vertical height. And this will give us the constant.
In our experiment, we had to measure the volume, mass, and density of the football. We used a weighing scale to estimate the mass of the ball. We recorded the readings based on 3 instances to get the final mass of 0.833 kg.
To get the volume of the ball, we had to fill a pail to 8 liters of water and use the same force for all 3 instances. The difference between the water flowing out of the pail and the original water capacity was determined as the volume of the ball. After doing the experiment based on 3 attempts, the average volume of the ball was 0.913 liters.
Since we could find the average mass and average volume of the ball, we could then derive the average density. However, we could not calibrate the values of certain variables such as pressure due to the lack of resources. Thus, I will be comparing 2 different scenarios in which pressure can be applied using force divided by area, assuming force is constant. The first scenario is when toes are in contact with the ball. Since the toes has a small surface area, higher pressure is exerted. Thus, you will notice that footballers out there use this technique for power shots. The second scenario is when the inside foot is in contact with the ball. Due to the large surface area of the foot, lower pressure is exerted. Thus, many footballers out there use it for accuracy.
There are factors to consider in how to kick a ball. These factors include gender, height of the footballer, part of the foot to exert a force, placement of the ball, distance between the ball and the goal, and precision of the footballer. There are factors, however, that may affect our calculations and limit our findings. These factors were either impossible to calculate or due to the lack of resources available. These include force exerted on ball, maximum height of the ball, and air resistance.
Energy cannot be created or destroyed, but can be converted from one form to another. In this case, when the ball is stationary on the grass, it has chemical potential energy. When it's being kicked, it is converted to kinetic and heat energy. And when it's finally stationary again, it will be stored as chemical energy. Before she kicks the ball is at rest. Newton's first law states that an object either remains at rest or continues to move at a constant velocity, unless acted upon by an external force. In this case, her kicking the ball is the external force.